Presenting an overview of key operating system concepts, we will explore the fundamental mechanisms that enable computers to function efficiently, including user and kernel modes, system calls, compilers, and the JVM. Let's get started. Understanding the user mode and its limitations. First, let's talk about the user mode. When we run applications on a computer, they operate in user mode. This means they have limited access to the system system resources like memory, hardware, and other processes. The reason for this restriction is security. User mode prevents applications from making unauthorized changes to the system. However, this also means applications can't directly interact with the critical system resources. This makes the system calls necessary. And the kernel mode, the heart of the system and runs with the full control over the system. Kernel mode manages crucial functions such as process scheduling, memory allocation, device drivers, and interrupt handling. Because of its high-level access, errors and vulnerabilities in kernel mode can compromise the entire system and managing applications and the operating system. Since user mode restricts direct access to the system sources, applications use their system calls to interact with the OS. System calls serve as a bridge between applications and the kernel, handling tasks like reading files, creating processes, and managing network connections. This mechanism ensures security while allowing applications to request necessary resources. Comparing the compiler and interpreters. Next, let's compare the compilers and interpreters. Two approaches to translating programming languages. A compiler converts the entire high-level code to machine code for execution, making it faster at runtime. An interpreter, on the other hand, translates and executes the code line by line, making it slower but more flexible for debugging. That's what the interpreter. And JVM. JVM is a platform independent. One of the best examples of an interpreter-based system is the Java Virtual Machine or JVM. When Java code is compiled, it doesn't produce machine code directly. Instead, it generates bytecode and intermediate representation. The JVM then translates that bytecode into machine level code based on the system and it is running on. This allows Java applications to run on any platform with a compatible JVM, providing independence. And real-world applications of OS principles include OS concepts are applied in various real-world scenarios. Mobile OS like Android and iOS for managing applications and resources for smartphones. And Cloud OS supports virtualized infrastructure and cloud computing. Servers, browsers, websites, database, and enterprise applications. Understanding these OS principles is essential for software development and IT infrastructure management. And key takeaways of future OS technology is like the kernel is the core of the operating system, managing and system control and system calls that provide a secure way for applications to interact with the OS. And JVM enables platform independent software development. As the technology advances, OS design will continue evolving to support emerging fields like cloud computing and edge computing. And that concludes my presentation. Thank you for your attention, and I am happy to take any questions you have.